So now let us discuss about the Fourier cosine and Fourier sine transform. So let f of x be a real valued function defined on positive real numbers. So then the Fourier cosine transform of f of x is given by integration from 0 to infinity f of x into cos ux into dx, right? And integration from 0 to infinity f of x into sine ux into dx for the Fourier sine transform of f of x. So now let us solve the first question. So we need to find the Fourier cosine transform of f of x. So here f of x is given. So before that we need to write a real line here from 0 to infinity, because since we are dealing with the Fourier cosine transform. For the Fourier transform we need to write from minus infinity to plus infinity. Here we need to consider 0 to infinity, and we need to mark the 0 to, right? So this is 2. So observe here from 0 to 2 we have one value of f of x, where what is f of x here? F of x equal to x. And otherwise in this region we have f of x equal to what? F of x equal to 0. So we need to split the integral from 0 to infinity as 0 to 2, whereas f of x equal to x, plus 2 to infinity, whereas f of x equal to 0. So first let us write the formula of the Fourier cosine transform of f of x. Now let us split the integral from 0 to infinity as 0 to 2 plus 2 to infinity. So here from 0 to 2 the f of x is x, from 2 to infinity the f of x is 0, 0 into cos ux is 0. So now we have only this portion, this is the entire thing is 0, right? So now how can we integrate this? So we have to apply the Bernoulli rule. So what the Bernoulli rule says, if you have the first function, the integration of first function into second function, whereas the first function necessarily a polynomial in x, right? The first function must be a term which should be equal to 0 after finitely many times of differentiation, right? Then only we can make use of the Bernoulli rule. According to that, so we have to write the first function as it is, and we have to integrate the second function with alternative sign minus. Again we have to differentiate the first function and integrate the second function, right? Again with alternative sign we have to perform differentiation integration until we get 0, right? So since we have a polynomial as the first function, definitely after finitely many times of differentiation it will reduces to 0, right? So here the first function is x and the second function is cos ux. So first function, I'm doing the integration now, into integration of cos ux. What is the integration of cos ux? It is sine ux divided by coefficient of x, that is u. We should write that in bracket. With alternative sign minus, we should perform differentiation integration until we get 0. So what is the differentiation of x? It is 1. What is the integration of sine ux by u? It is minus cos ux divided by u, but already we have another u here. U into u is u square. Again with alternative sign we should perform differentiation integration. What is the differentiation of 1? It is 0. So we should stop here. So this is the lower limit and this is the upper limit, right? Okay. So now let us simplify this. So now let us consider upper limit minus lower limit. Let me substitute x equal to 2 now. So what happens? It is 2 into, so sine 2u divided by u plus cos 2u divided by u square. This is the upper limit minus lower limit. Substitute x equal to 0. So 0 into anything is 0, 0 plus cos 0, cos u into 0, it is cos 0, cos 0 is 1, it is 1 by u square, right? So we have the final answer is given by. So let us solve the next problem. So look at the second question. We need to find the Fourier sine transform of f of x. So here f of x is given. Again we need to draw a real line from 0 to infinity. So we need to mark this 1 and 2. So this is 1 and this is 2. So here from 0 to 1, in this portion, your f of x will be x. It is given. From 1 to 2 in this region, your f of x will be 2 minus x, right? And if x is more than 2 in this region, so your f of x will be 0. So let us write the formula first. So now let us split the integral from 0 to infinity as 0 to 1, whereas your f of x equal to x, plus 1 to 2, whereas your f of x equals to 2 minus x, plus 2 to infinity, whereas f of x equal to 0. So we have this. Once the integrand is 0, the whole thing is 0, right? So here, look at this. We have to find the integration of this. The first function is a polynomial here. It is vanishing after finitely many times of differentiation. Vanishing means equal to 0. So we can apply the Bernoulli rule. According to that, so it is, so first function into integration of sine ux. What is that? It is minus cos ux divided by coefficient of x, because we are differentiating with respect to x. Minus, with alternative sign, we have to perform differentiation integration until we get 0. What is the differentiation of x? It is 1. And what is the integration of minus cos ux by u? It is minus, so sine ux divided by u into u, it is u square. Again, with alternative sign, we have to perform differentiation integration. What is the differentiation of 1? It is 0. We should stop here. So this is the lower limit and this is the upper limit. So plus. Now let us calculate the integration of this. So again, 2 minus 6 is a polynomial. So we can apply the Bernoulli rule here. Fine. So first function, we should write that in bracket. And what is the integration of sine ux? It is minus cos ux divided by u. Again, with alternative sign, we should perform differentiation integration until we get 0. What is the differentiation of 2 minus x? The differentiation of 2 is 0 minus the differentiation of x is 1. So it is minus 1. And the differentiation of minus cos ux by u is minus sine ux divided by u into u. It is u square. Plus, we should perform differentiation integration. What is the differentiation of minus 1? It is 0. So this is the upper limit and this is the lower limit and this is the upper limit, right? So let us simplify this. Okay, so we simplified this. So here 2 minus x into minus cos ux is there. We can multiply this minus 1 to this 2 minus x so that we have x minus 2. So on simplification we have this. So now let us calculate the upper limit minus lower. Let us substitute x equal to 1 now. What happens? Minus, let us substitute x equal to 0. So 0 into anything is 0 plus sine 0, u into 0 is 0. So sine 0 is 0, right? Plus, again, let us calculate the upper limit here. So put x equal to 2. So 2 minus 2 will be 0. Minus, here it is sine 2u divided by u square. This is the upper limit minus lower limit x equal to 1. So it is 1 minus 2, which is minus 1. It is cos u into 1, that is u divided by u minus, so sine u divided by u square. So on simplification, so we can cancel this minus cos u by u plus cos u by u. So let us write the remaining thing. So this is the solution.